Hi, my name is Andy Mallet, and this is Glimmer DSL for SWT tutorial number 16. So today we're going to go through an elaborate sample. We're going to go through weather. So weather is a sample that brings a number of concepts from Glimmer DSL for SWT together, such as multi-threading, such as data binding, and canvas graphics as well. So this is a sort of a demonstration of a realistic example that will actually also contact a web service API. So let's get started by launching it. So there you go. As you can see, it's a very simple app. All it shows is basically a location, like a city, the city of Montreal in Quebec, Canada. And underneath, it gives me the temperature, the min, the max, what does it feel like, and humidity. And then if I want, I can switch to Fahrenheit. So then it gives me the same values in Fahrenheit instead of Celsius. And let's demonstrate entering different values. For example, let's put in San Diego. And if I hit enter, it'll show us the weather for San Diego, and it does some sort of a guessing for the location, so you don't have to type in the full address. But if I want to put a fuller address, like let's just say Chicago, Illinois, USA, it also accepts that, and it shows us the temperature in Chicago. But I mean, you can even put Antarctica. And there you go. Give us the temperature in Antarctica, which is very low, minus 44 in the summer. So, and that's in Celsius, but we can also see the Fahrenheit. So that gives you a pretty much a good overview of what the weather app is. One thing to note about it is that we have a sort of a border over here around the weather area. And this is done using canvas graphics. So it takes advantage of the canvas Shape DSL. So let's steer this aside. Let's move it aside and take a look at the code. So to get started, we have basically a weather class, which is a custom shell, meaning it's a custom window, meaning it's an app. And we have a few constants, and then we have some attributes on the weather class. So in a way, we're using a view that is an active view, like a smart view that has its own attributes. And before we get started, we're initializing a mutex, and then we're fetching the weather with the default city being Montreal. And the after body, meaning after setting up the GUI, we launch a thread that will loop, and every 10 seconds, it'll actually as long as the body root hasn't been disposed, meaning the app hasn't been closed, it'll fetch the weather again. So it'll keep updating the weather every 10 seconds. And it's happening in a thread because fetch weather, if we were to look at it, it's actually contacting a web service. So here's the fetch weather method. You can see it is using net HTTP. A built-in Ruby library for contacting web services, and it basically parses the weather data as JSON and then stores it in the weather data attribute. And it's using a mutex because it could get used from inside a different thread. So we want to make sure that if multiple threads competed, the mutex will ensure that only one of them will be accessing the data. The web service, and then storing its result. And then if we were to get back up and then go into the body of the GUI, we have a shell. It has a style of no resize, meaning you cannot resize it. It has a predefined width and height. So the minimum size of 400 by 300 is the size it'll get. And then we have a text field, and this is where we check the city. So it is data bound to the city attribute on self, on the view object itself, or the view class, the view instance actually. And then on key pressed, so if I were here to press a key and then the key ends up being equal to carriage return, then we're gonna fetch the weather again, and we do so in another thread. And again, we do so in another thread to avoid freezing the GUI. You don't want the GUI freezing when the web service is being slow. That way you decouple the GUI from the network latency. So that's the benefit of using a different thread. And then if we were to go down now, so we have a tab folder that has two tabs. So as you can see here, we have the Celsius tab and the Fahrenheit tab. And within each, you can embed canvas graphics directly. So we're embedding a rectangle that has the width, the default width and height of its parent -2, meaning it's a little bit smaller. So that's how you do it. You pass an array with default, comma, -2, and that's how the canvas Shape DSL will automatically then use the parent width and height, and then deduct 2 from each. And then it's got this is a rounded rectangle because it's got 15 and 15 here, meaning the angles for rounding the rectangle on the width and on the height. So that means, as you can see here, it's a rounded rectangle. So that's what the 15 and 15 are. And it's got a foreground of default foreground, which in this case it looks like it's white. And then afterwards, within the tab item, we declare a bunch of temperature fields. So we have what we have here is basically a method-based custom widget. So in a sense, TempField is a custom widget. So we made a custom widget that's like a pair of values, like the label and the value over here. Like it takes a field name and a temp unit. So so this is the TempField custom widget, which is method-based, and this is the humidity field custom widget, which is also method-based, meaning they're defined as simply just methods. So we have a temp field here as a method that has a name label, for example, temp or temp min, and then it's got another label that has the value, which is data bound unidirectionally, whereas whenever the field name gets updated, so if the temperature minimum gets updated, it'll automatically get notified of the change and it'll reflect it in the GUI. The humidity field is similar, but the difference is that when we format them using the on-read converter, this one gets a % at the end, whereas the others get the degree at the end. And this is and you can compose custom widgets out of other custom widgets. So we have a named label custom widget here, which keeps all the default reusable font and background color and foreground color. So that's the benefit of using custom widget instead of just a plain label. It's to avoid repeating all of this information multiple times. All you have to do is just say a name label and pass it the text, and it does everything for you. And this is in contrast to class-based custom widgets, which are different from method-based custom widgets. Method-based custom widgets are usually declared, within the same class, and they're for very quick reuse of GUI code. But once the logic grows too large to fit in a small method, you might want to consider the class-based custom widget approach, which is to declare a class per keyword for a custom widget, which we can cover in a different tutorial. But if we were to continue to look at what weather data does, this one receives the JSON data, and then it sets all the different attributes. And as soon as they get set, the data binding that we saw earlier kicks in, and it updates the values here. At the bottom here, there are just helper methods that, because we received the data from the API using Kelvin from the Open Weather Map API, and then we convert the Kelvin units to Celsius and Fahrenheit as needed. Yeah, that pretty much covers what the weather application is. In order to learn more about Glimmer DSL for SWT, check out the GitHub project.